Hi, my name is Jeydy, and this presentation is about the physics of LASIK eye surgery. Regardless if you don't have 20/20 vision or you do, I think the physics behind LASIK is pretty interesting, and yeah, just stick around. So what LASIK stands for is laser assisted in situ keratomylosis. So it's a mouthful, but that's what it stands for. And this eye surgery is generally meant to remove an individual's dependency on eyeglasses or contacts. So if you have eyeglasses or contacts, you've probably thought of this eye surgery before. You've probably considered it. And if you haven't, you probably will. A little history. This man was a Russian eye surgeon and was the first to develop radio keratomy. This is a surgical procedure used to correct nearsightedness in the 1970s. This included making tiny radial incisions in the corneal surface. Downside about this procedure, though, is that it relied heavily on the manual skills of the surgeon, so it wasn't as precise as it could be and which is now. Um, this man was a Colombian ophthalmologist and developed a technique called keratomylosis in the 1960s. This was used to correct refractive errors, and it used a microkeratomy. Um, this basically removed a piece of corneal tissue which was frozen, reshaped, and reattached to the surface of the eye. Um, and just to show you a diagram of what this microkeratomy is, I added a picture that I found in the internet, and this is what basically cut the corneal surface, which is called the stromal bed. But I just wanted to read the next bullet point. The sculpting was at first done with a lathe and blade. So this is pointing out that the microkeratomy was actually a innovation, because at first it was using a lathe and a blade, but they then developed a microkeratomy, which is this diagram right here, and this slide is basically adding on to what I'm saying right now. Jose actually first performed this technique by freezing the corneal tissue disc, then used a lathe to remove this stromal tissue right here. So the microkeratomy was definitely a development from what a lathe is. I couldn't find a lathe, a diagram of a lathe where I could show you guys, but just know that it was an innovation. Speaking of innovations, the actual game changer was introduced when the excimer laser was created and used for the computer industry in the 1970s. Then in the 1980s, research team at IBM discovered this laser can be used to cut biological tissue with extreme precision. So not only was it beneficial to the computer industry, it was then found out that it was beneficial for the medical industry as well. In 1988, the excimer laser was used for the first time to sculpt the stromal bed. And then in 1990, the microkeratomy and the excimer laser was used together. So this diagram was introduced into the equation and resulted in LASIK eye surgery. Before explaining the physics behind LASIK, it's important to understand how vision works and why some people have eyesight problems. Our cornea acts as a window, which is right here. It receives light and transfers that light to our retina, which is back here in the back of the eyeball, where that is then converted to electrical signals in our brains. How does our retina receive that light? Well, as you can see from this diagram, light is refracted in the cornea right here. However, for some people, light is not refracted correctly, also known as a refractive error, which causes these eye problems. LASIK allows the eye to be altered in order to solve these refractive errors. So now that brings us to the mechanism behind LASIK. The LASIK eye procedures take about 15 minutes each eye. Patients will be given topical eye drops that help with the uncomfortableness of the procedure. And then I will be propped open by an eyelid speculum. This is the device. I would show you a picture of the device in an eye, but it's really uncomfortable, so I just didn't. Now the mechanism behind LASIK, the actual procedure. A ring is placed on the eye, putting pressure on the cornea. The cornea is cut by the microkeratomy and is lifted carefully to one side. The eye is centered by a red light. The ultraviolet laser is used to precisely change the shape of the cornea. And then tiny portions of its interior are vaporized to make the shape, to correct the shape. And this is just another diagram too. I showed you one here, but this is just another one for you to get more visuals. And to continue, the cornea flap is replaced and a small antibiotic is added to the eye, helping the cornea heal and rebound immediately from the cut. The cornea flap does heal quickly, so it's a very fast procedure, and that just shows it. Now I want to talk about go more into depth about the laser. It's made up of reactive gases like chlorine and fluorine, and it's also made up of inert gases, which is argon, krypton, and xenon. The laser is formed when these gases mix, making a short-lived, excited, unstable molecule that quickly emits a UV photon of a particular frequency. These gases are held inside a tube seal with mirrors. One of these mirrors allows the light to escape, making the UV laser beam. But this laser does not heat the cornea, but it rather breaks molecular bonds of organic material. The beam is microscopic and less than a nanometer wide. The surgeon controls the size, position, and number of laser pulses applied. These pulses come from a computer-controlled excimer laser, like the one we were talking about before. So some improvements have been made. One of them has been the wavefront LASIK surgery. To explain what a wavefront is basically the rays of light and the image that they carry. So we talked about this concept earlier in the presentation. Rays of light hit the cornea and is refracted by the cornea and is transferred to the retina where the electrical signals are created by the brain. So this is the same concept. The wavefront is getting distorted by the imperfections in the cornea or lens. Therefore, an exact image is not formed. This is the case for people who are nearsighted, farsighted, etc. But in the wavefront guided LASIK surgery, imperfections are measured in the wavefront and are corrected, thus correcting the way an individual sees. Wavefront LASIK allows for greater personalization and precision. So since the wavefront is measuring exactly where your imperfections are in the cornea or the lens, it's really precise. Personal eye characteristics of an individual is evaluated, and excimer laser is programmed with this information to reshape the size. It's expensive, but there's a lower chance of an individual losing their vision, which actually brings me to my pros and cons list. So for the pros and cons list, more than 90% of people who receive LASIK eye surgery achieve 20/20 vision. That's a pretty big percentage. For a con, side effects, dry eyes, burning, and itching. This affects 20% to 40% of people who undergo LASIK eye surgery. Um, the chances are low, but the side effects still may possibly be there. For the pros, no longer have to wear glasses or eye contacts. I know that I'm looking forward to getting LASIK eye surgery because I do not want to wear eyeglasses anymore. It's a nuisance, and being able to see 20/20 is definitely an advantage that a lot of people should have. But it is what it is. Not everyone can get it. Usually people ages older of 40 can't get it. It just causes a lot of complications, and that is a con. A pro, there's quick results because the cornea, like we talked about before, heals quickly. There's quick results. So obviously there's still some, you still can't, go driving after a LASIK eye surgery, but there's definitely quick results and you will be able to see them within the week. Another con, uncommon side effects, even though they're uncommon, they're still there. There's nighttime glare and hollows, which could be a little uncomfortable for some people or for everyone that may get them. A pro, the procedure is quick. The whole, it takes 15 minutes. Um, I've heard 5 each eye. It's a quick procedure and there's quick results. So that's the pros and cons list, and this is my works. Cited in my resources. So thank you so much.